We will now build our first model, a population model that has a single stock, population, 1 inflow, births, 1 converter, birth rate, and 2 connectors, one from birth rate to births and the other from population to births. At the end of the video, I will ask you to extend your model by building a deaths flow that will be affected by a death rate. For now, let's get started. At this point we have a stock, population, with a flow in, births, and a converter, birth rate. Remember, stocks are things that increase or decrease, like the number of people or population. Flows determine the rate at which a stock will increase or decrease. In this model, the number of births at each time period flow into the stock population. Finally, converters are those variables that determine how open or closed the flow valves are, essentially the rate at which the rate, flow, is adjusted. We now need to create relationships between population, births, and birth rate. We do this by using the connector icon and creating a relationship between birth rate and births, and population and births. In essence, we are saying that the number of births at time 2 is a function of the population, or number of people, in time 1 times the birth rate of the population.
We now have our first model. By clicking on the Model tab we can begin to enter the variable information necessary to simulate the model. The initial value for a stock, population, that is the beginning population for the simulation, is 100 people. The birth rate for this population is 5%, or 0.05. The flow births will be a simple multiplying of the population times the birth rate. Once these values and equations have been entered, we will be able to simulate the model. Once the model is ready to run, and you know this by the fact that none of the variables has a question mark inside them, we can simulate. Our variable of interest, here, is population. Since the birth rate is a constant, this will change as we expand the model. and the number of births each time period is a simple function, birth rate times population. We have several options for output, from graphs to tables, to matrix, and for this first model we will be using the graphing tool.
We now need to establish the initial simulation parameters. Our time will be 12 years, from time 1 to time 13, and we will leave all of the other parameters the same, but we'll be exploring them in later models. Congratulations! You have just built your first Stella model, during which you utilized all of the primary Stella icons, stocks, flows, converters, connectors. You used the map and model tabs, and created a behavior over time graph for the variable, population. Your assignment, the results of which should be posted by Sunday, are to extend the simulation from 12 to 50 years and determine the final population value. Next, add a flow out, called deaths, that is affected by a converter called death rate, which is set at 3.5%, and run the model again for 50 years and provide, for the simulation, the final population value. Hint: remember that the deaths flow is a function of the death rate and population. See the births flow algebra. Well done! Isn't this fun?